Chapter 3, Section 6, the slope-intercept form. This is a form. It's not really any new properties for algebra. We're going to look for a very good, effective strategy to graph. It's the most preferred method to do graphing, though you'll be expected to know the other ways using intercepts and guessing and solving, I guess, would be a way to find the ordered pairs and those kinds of things. So we're going to go through that, what the y-intercept and the slope, how it can be used to graph a line. We're going to get equations into this slope-intercept form, it's called, and then we're going to graph using that form, and then we're going to talk about some special lines that occur, which is really related to slope. So we're going to talk about those things in this section. Well, they keep on tying into this upgrading a computer network, or how much a computer is going to cost. This is kind of review. We go through what is slope, which is the change, the amount of rise that occurs, and the denominator is the change in x, which is run, which is given by the slope formula. Again, remember that this is dealing with a difference or a subtraction, so you have to keep things in the right order. That's why they go to this extent of making sure if you start with the y coordinate of 0.2, you got to make sure you start with the x coordinate of 0.22. And if you don't do that, your slopes aren't going to be right. And that's where they define these points, and that's what that sub notation is about, is saying, hey, I can have a 0.1 and a 0.2. How do I know which one's which when I'm talking about multiple y coordinates and multiple x coordinates? So to get the slope, if I have 2 points, I can get the slope. I can take the y coordinates from these 2 points, and in this case they say this is 0.2. That's why they put this here for y sub 2 is 7, the y coordinate for 0.2. And they subtract 4, which comes from the y coordinate of the 0.1, the y sub 1. So the difference of the y coordinates over the difference of the x coordinates. Now I got to make sure, since I took the 7 from this point, I got to make sure, and I put that in the beginning of the subtraction, I need to put the x coordinate from that point first too, and then the x coordinate from the next one. Well, we do the differences, the subtraction, we get 3 over 2. Now, knowing that the slope is 3 over 2, if I have 1 point, really that's like a map to the next point on my line that will be the infinity of ordered pairs that solve this equation. So that's what they're showing us. If I have this point 0, 4, which is one of the points, if I went up 3, that positive 3 in the rise portion, or the numerator of my fraction, up 3, and which is positive 3, and to the right 2, I end up at my next point, which is 2, 7. Now it's very possible, if this would have simplified the fraction, we wouldn't necessarily go to the exact points that we got the slope from, but I would go to another point on that infinity of points that make up the solution, that linear solution, or that line. So the next thing they have us do is just draw a line using a slope and the y-intercept. So I have a point, basically the y-intercept. I know this is y-intercept because the x coordinate is 0, right? So I know I have a point which is 0, 2, which is right here. And if I have a slope of 4, I can say, how do I get to the next point? Well, I go up 1, a positive 1, and to the right 4. And I end up at this new point right here that I don't really even need to know what the ordered pair is. All I have to do is draw a line through those 2 points, and I have my graph, right? Now, we went through this whole thing about making sure I have 2 points or 3 points when I do a graph. Well, you could do the slope again and get a third point, but if you got the wrong slope, or if you don't know how to use a slope, you're going to just get another wrong point that happens to stay on that same wrong line. So it really is good enough just to do that one other point, and hopefully you didn't make an error. So basically they're showing us if I have a point and a slope, in this case it happens to be the y-intercept, I can graph the line. And that's really all the information I need to graph. And then they go through these examples here, and they say, let's look at this y equals 2x plus 3. Well, to find out the y-intercept, the x-coordinate needs to be 0. So if I put 0 in for x, y equals 3. In other words, the place where this line that goes is the points of all the solutions for this equation, where it goes across the y-axis is going to be the point 0, which all points on the y-axis are 0 for x-coordinate, and it's going to cross at 0, 3. And they want us to notice that in this form that they're going to introduce to us, which is y equals mx plus b, that we could probably just go directly to what's being added in this form and say, you know, I can pull the y-intercept from that very easily. Now 3 is not the y-intercept. The point 0, 3 is the y-intercept. But that's a good thing to remember. If I'm going to be on the y-axis, the x-coordinate is always 0. So they're starting to say, hey, we can get valuable information very quickly from this form. Well, the slope, again, they remind us, is the change in y over the change in x. And if I took two ordered pairs from this, like 0, 3 we know works, but if I put 1 in for x, y would equal 5. That would be 2 times 1 plus 3, so y equals 5. There's another solution ordered pair for this. If I took these 2 points, now I can find the slope. I take the difference of the y-coordinates over the difference of the x-coordinates, and I get 2 over 1, or 2. And they want us to notice that, hey, that number times x is the same as the slope, and that's exactly what we're going to look for is in that pattern, that always does stay that way. So they tell us this. They say if you have an equation solved for y, now let me say that again. If I have y equal to something, that would be solved for y. It is technically in the slope-intercept form, unless you do things like division at the wrong time, and we'll talk about that. Multiplying by reciprocals is a lot better way to deal with multiplication, especially when we get into these types of equations. So when I solve for y, I get some number times x. That number times x is the slope of the line. And b indicates where the y-intercept is. So it'd be the ordered pair 0, which is the first ordered pair, first number of ordered pair is the x value. If it is on the y-axis, it has to be 0, and then whatever that number is, b, will be the y-coordinate. So understanding the information given to us when it's in this form, we can very easily, like this one, graph this. Now y equals 5/4 x minus 8. Now does it say subtraction up here? No, it has to be an addition. So you need to change this to an addition. So it would be y equals 4/5 x plus negative 8. So what is my y-intercept? It would be 0, negative 8. Now the slope would be 4/5, so from that point on the y-axis, which we're going to show you in a little bit, I would go up 4 and to the right 5, and that'll be my next point. I can draw a line through those 2 points, and I have a graph of all the solutions for this equation. This one I need to solve for y. I can solve for y by adding a negative 2x to both sides. And then I get y equals negative 2x plus 5. Hey, there's my y-intercept is indicated, and my slope is a -2. Same thing here is a little harder to solve for. Let's look at how the book does it. Well, here's that first one. They say, well, we need to make sure it's an addition first to get my indicator for my y-intercept, which is 0, -8, not 0, 8. And then my slope is 4/5. And that's all they're asking for this, is what's the slope and the y-intercept. Well, this one we have to solve for y. And I kind of talked through this. I add a -2x to both sides. Notice they're not showing all the steps now like they do in chapter 1, but this is just the addition principle in use. And these are equivalent equations, which means the solutions to this equation and solutions to this equation are exactly the same. But in this form, I know I have a -2 slope and 0, 5 is my y-intercept. Now here, when I was talking about division can get you in trouble, let's look at how they're solving this one. They do talk about the steps. Well, they add a -3x to both sides, and you end up with -4y equals -3x plus 7. This is not in the right form yet because it's not equal. Y is not equal to something, or it's not solved for y. Now, something I do with especially subtractions is I would change this to an addition right away. I see a lot of errors here where you do the right thing, you add a -3x to both sides, and then you forget that this is really -4y. So be careful there. Well, now the other thing too is we tend to say, well, the easy way to do this on paper is to divide this by -4 and then divide this by a -4. Well, I'd end up with -3x plus 7 all over -4. Is that in the slope-intercept form? No. But if I use the reciprocal of -4 and I multiply both sides by its reciprocal, that's the same as dividing by -4, or better yet, with reciprocals, when I take -1/4 times a -4, I get a +1. That's what I want, 1 times y, which is y. Then also, the sides of an equal sign are like grouping symbols, so I have to take a -1/4 times this entire side. So I use the distributive property, distribute this multiplication of -1/4 times -3 times x, which is, I should look at the sign, I know it's positive, I end up with 3/4, and hopefully you're at the point where that is obvious to you. If not, you need to review your fraction multiplication a little bit. And then I need to distribute here. I take -1/4 times 7, and I get a -7/4, or they write it as a subtraction, which then we have to think about it back as an addition. So I would just write it as 3/4 x plus a -7/4, because -7/4 is the y coordinate of my y-intercept, which is 0, -7/4. So there's my y-intercept, and here's my slope, 3/4. Then they take these two items and say write an equation from this. Well, if I put this back in here, I have the y-intercept and I have a slope. Well, I could remember what the form is and just say y equals -12/5 x plus 11. And there is your equation. Now they go through some examples here about fast food menus. Notice this graph has this squiggly here because they jump scale here, right? Remember, slope's the same thing. I tend to see a lot of students, once you give them a word problem, it's like, oh, now I gotta start writing all kinds of things all over my scratch paper. Your goal in this chapter, especially if they have a word problem, you're going to figure out ordered pairs. Usually you're going to get basically some kind of graphical representation. You might be able to write the ordered pairs without doing the graph paper, but that's the goal, because we want ordered pairs, because then we can work with ordered pairs and get slope, and we can also if we know what the y-intercept is, which is right here 0, 90, because I know this is y-intercept because the x-coordinate is 0. This is the y-coordinate, and here's the slope of 6. Here's my equation, and it should be that easy. Then they get into graphing in the slope-intercept form. So that's what we do. The next step basically is we can get the slope and a point. Once I have a point and a slope, the slope tells me where to draw the next point on my solution line. So that's all you do. A lot of words here for that, but basically this picture shows it all. Is if I have this y-intercept of 0, 5 and a slope of 3/4, means I go up 3 and to the right 4. But also you need to remember that if I have this positive fraction, this relationship between these two numbers, what if it was down 3, negative 3, and to the left 4? Well, that's still a positive 3/4. Negative over negative is positive. Or if you think about simplest form, they have a common factor of a -1. Simplest form by definition means that you have the numerator and the denominator only have one common factor, and that's 1. Well, -3 over -4 has two common factors. It has 1, but also you can put it as -1 over -1, which is the definition of 1. So here they're showing you solve. If it's not in the slope-intercept form, put it in the slope-intercept form. Notice they're using reciprocals all the time now. Before they used division every once in a while. But reciprocals is what we need to do here to get it into the proper form. Then they talk through all this stuff again about how do you do this. It's a good read, but I like pictures, and that's why we do graph things, because it becomes very visible what's going on. So we end up with the y equals -2/3 x plus 1. Well, my y-intercept is 0, 1 right here, and my slope is a -2/3. Now I could write that as -2 over +3 or +2 over -3. Either one would work. In this case they go +2 over -3, which would be up to a +2, and back or to the left 3, which is a -3. So 2 over -3 is the same as a -2/3. And that's what they're showing here, right here in this box. Well, I could go the other way. I could go -2 over +3. If I go down 2, that's a -2, and to the right 3, that's a +3. I end up with another point on this line of all the solutions for this equation. Now, parallel lines and perpendicular lines have a relationship with their slopes. So if I have a line and I know the slope of this line, and I say I have another parallel line, I'm going to be able to tell you something about the slope of that line. And if you think about that, the comparison to rise over run, for two lines to be parallel, they have to have the same rise over run. If they had a difference in the angle that they're going on your graph paper, eventually they're going to intersect and they would not be parallel. Okay? So that's what they're going through here too, is they say if the slopes of the lines are the same, the lines are parallel. So if I put something in slope-intercept form and they have different y-intercepts but they have the same slope, I know that they're parallel just by looking at their slope. Okay? And I don't see a graph. We'll look at some here. But that, it seems like, if you think about that, you know, the angles of the line are slope. And if I have two lines in there, for them to not intersect, they have to have exactly the same slant to them, or technically the same slope. Now, perpendicular lines intersect in a special way. Perpendicular means that they cross making 90-degree angles, or right angles is another word for that. And what they're showing us here is that the relationship between a slope of a perpendicular line, of perpendicular lines, has a relationship, and it ends up to be the negative or reciprocal of each other. Now, there's some things I should point out. If you look at this line right here, what is the slope of this? This is a positive slope. It's going up as I go from left to right. This one is a negative slope. So if I said they're reciprocals of each other, I would have slopes that have the same positive or the same negative sign, which doesn't happen. If this one's positive, its perpendicular is negative, or vice versa. Well, what they're showing here with right angles and stuff is that the relationship they have is the product of them has to equal -1. Now, it kind of relates to reciprocals, because we used to say the definition of a reciprocal is when you multiply a number times its reciprocal, you get 1. Well, if you have perpendicular slopes, when you multiply those slopes together, you get -1 right here. And that's what they're saying. If two lines are perpendicular, the product, the answer to the multiplication of those two numbers, will be equal to -1. And then if it says if one line is vertical and the other line is horizontal, they are perpendicular. Or if one's vertical, then we know its perpendicular line is horizontal. And why they do this is that with horizontal lines we have no slope. So how do you get something to multiply by a non-number and get -1? So that's just kind of like a special case, but it's good to remember that there's a relationship if they're perpendicular. So what are we going to do with this? Well, if they give us an equation and they tell us something like these are perpendicular, or determine whether they're perpendicular, well, I know the slope of this one right away. I should from the slope-intercept form. The slope of this one is 1/2. The question would be, I wonder what the slope of this one is. Well, we solve for y. We put it in the slope-intercept form, and I go, oh, okay, y equals, so the slope is -2 for this one. So what determines if they're perpendicular? If I take -2 times 1/2, I get -1, which means that they are perpendicular. And that's it for that. So this is the preferred method of graphing, is the slope-intercept form. It's very, very useful, and that's less steps. Good strategies are the least amount of steps, least amount of chances for error. That's a good strategy.